Okay, so we're now going to start 3.4 notes, and that is going to be function notation. So we're kind of did notes down here. Now we're going to bump back up to function notation. I just want to say function notation is when something is written like f with parentheses x, something like that. That's an f. There's not apostrophe or anything, just an f. It could be a g, could be an h, but it's some lowercase letter with parentheses of some variable inside, okay? It's just a quick way to evaluate a function for a given input. I want to pay attention that we say this is f of x. That's how that would be said. That is function notation is f of x equals, that's equals something, okay? F of x is the same thing as saying y equals, okay? We can interchange those. Y equals, f of x equals. So if you go to the problems on page 9, go to 8, we're going to look at this, okay? Before we even actually do function notation, I'm going to go over this little example here. For health class, Jason had a record. Let's start that over. Jason had to record his distances each hour. Use the graph to answer the following questions. How far does Jason travel after traveling 1 hour? So my time here is along the bottom, and 1 hour is here. So here on the graph is at 1 hour, and that distance on his bike says it's 12 miles. So we would read it like that, okay? Now, if this was an equation, I would have plugged in 1 for the time, and I would calculate the 12. How long did it take him to ride 18 miles? Well, 18 is right between the 16 and 20, and then that would go down to about 1.5 hours, okay? And then if this were to continue, so if we continue our graph, where would he go in how far would he go in 4 hours? And we need to explain how we know that. So I would say, I know in 1 hour he's going 12 miles, and this is a constant rate of change. It's a straight line. So that means if he went 36 miles in 3 hours, and I go another hour, I need to add another 12 miles. So he's actually going to go to 48 miles, and I know this because it's a constant rate of change. And that rate is 12 miles every hour. Okay? Now, that leads us into this function notation. So I want to talk a few things about the function notation before I give you some examples. So often equations are written in the form of function notation. Again, it's the same thing as saying f of x. I could put in for y. It doesn't matter, okay? If f is a function and x is the domain, then f of x represents the output of f corresponding to the input of x, okay? The parentheses do not imply multiplication. It is actually the value of the function of f at the input of x, and we read that as f of x. The letter f can be used to name the function, and it can be any letters, okay? These are just the most common. F is the most common, but other ones are listed as well, and you can see other ones here. We got H, we have G, we have F, okay? So to evaluate, here is an equation in function notation. It says f of x equals -3 times x minus 2. And I want to find the following. Well, instead of having f of x, this is f of 3. So that means in function f, which this is function f with respect to x. Okay, that means x is the variable in that function. And this tells me I want f of 3. So instead of the variable x in that function, I'm going to put 3. So I just rewrite my function the exact same, except where there is x, I'm going to put in 3. So I have -3 times 3 minus 2. So there's no more x. Okay? Negative 3 times 3 is negative 9 minus 2 is negative 11. Now it wants function f, same function, but it wants f of negative 1. So instead of x, I'm going to have negative 1. So it's negative 3 times negative 1 minus 2. Negative 3 times negative 1 is 3. Minus 2 is 1. Okay? Now, number 3 gives me h of x. Well, it gives me that function, but it wants h of 2. So instead of x, everywhere x is, so there's an x here, there's an x here, I'm going to replace it with a 2. So get in the habit of putting what you're putting in, so x is being 2, but it's also being squared. But what you're being in parentheses, just like it's in parentheses here, put it in parentheses there, because when you do have negatives, that's the most common mistake I see, is that negatives were not multiplied right or squared correctly or whatever. So 2 squared minus 5 times 2 plus 7, okay, and that's going to equal 1. You plug that in your calculator if you have to, or do it in your head. 4 minus 10 plus 7. And now I want h of x, so I take function h, and I'm going to plug, not x, of negative 5. I'm going to plug negative 5 in. So this is where that parenthesis really needs to come in handy. Because if you type in without parentheses around this negative 5 and then square it, it is not going to square the negative. It will only square the 5. But we know negative 5 times negative 5 is a positive 25. If you don't plug that in your calculator with the parentheses, the answer it gives you is a negative 25, and that would be wrong. So I have a 25. Negative 5 times negative 5 is positive 25. So 25 plus 25 plus 7 is going to give me 57. Number 5, it gives me the function g. Here is g of x, gives me this equation. And I want g of 9. So everywhere I see x, I'm going to put 9. Now this one, the equation has a negative. It must stay there. The equation in front of my x squared, or the equation, the negative. And then I plug in 9 because there was an x squared plus 10 times 9 minus 3. You are only replacing the x's. Everything else has to stay exactly the same. So now when you punch this in your calculator, it's not going to square the negative. That negative has to stay there because only 9 is being squared. So you get negative 81 plus 90 minus 3 is 6. Okay, now I want g of negative 3. So everywhere I have an x, I'm going to put in negative 3. Well, the equation has a negative. Then I plug in my x, of which is negative 3. Okay. I just rewrite the equation. No x's, putting that in. Okay. You put this in your calculator. You should get 42. So it's negative, but negative 3 squared is 9. So I have negative 9. This makes a negative 30. So I have negative 9 minus 30 minus 3. It should be a negative 42. And I just wrote 42. I'm sorry. Give myself some space in my box here. Negative 42. Okay, you're going to do these ones on your own. Let's go down. Oh, I want you to look at number 6 first. See how it has 2 of them and a plus in between? You're going to find h of 1. So you're going to put 1 in for x and get a number. Okay, just like we got a number over here when we plug something in. Then you're going to find h of negative 7. Plug it in for x, get a number. And then this means you add those two numbers together, and that's how you get your final answer for number 6. Okay, let's go down to number 7 and talk about what the meaning of these functions gives you. So if I let, and this is supposed to say this isn't just t, it's f of t. Okay, let f of t, so the function f of t, be the outside temperature in degrees Fahrenheit for t hours. So t does not stand for temperature. It stands for hours after 6 a.m. So that's kind of key. And we want to explain the meaning of each. So when I have f of something, that's saying it's going to equal the temperature at that time. Okay? What's inside just means the time, but the function equals temperature. Okay? So if this says my time is 0, okay, that means I'm 0 hours after 6 a.m. because this is T is hours after 6 a.m. So that means I'm at 6 a.m. So at 6 a.m., this equals 58, so that means the temperature, so it's 58 degrees Fahrenheit outside, okay? Function equals temperature. That's what this is. Okay, so that is how I would translate number, well, 7A. And then 7B, I got to figure out the time. So this is 6 hours after 6 a.m. Okay, so I'm going to add 6 to 6 a.m. and you get 12, which would be 12 p.m. or noon. You can write either one. So at noon, it's 10 degrees Fahrenheit, if I can write it. Sorry, that's weird. N degrees Fahrenheit, because the function equals degrees of the temperature outside, okay? And then C looks a little different. So again, I need to figure out time. So this is going to be 6 a.m. plus 3, which would be 9 a.m. That symbol is less than. And then this is the function when it would be 6 a.m. plus 9, which would give me 3 p.m., okay, or 1,500 hours if you do military time, okay? Now, what does this mean? This is a function, so this means the temperature at this time is less than the temperature, because that's what the function meant, at this time. So you can just say it's colder at 9 a.m. than at 3 p.m. Or like I said, do military time and then 1,500, okay? So that's what you're doing even for number 8, except this time the function, the h of x, represents the percent of U.S. households with internet. Okay? So, and this just represents the number of years after 1980. The percent would equal 55%. Okay? So you can do these. I'm going to do B with you. And then you can do A and C. So we need to remember that the 27 is years after 1980. Whoa, I don't know what I'm writing there. Sorry. Okay, so that would give us in 2007. So I know I'm going to talk about 2007 here. This is the percent of households with internet. Percent of households. And that gives me a greater than sign. So that means more than that. This percent of 61 has to be the least amount. Okay. So this would be 61%. Since it does have an equal one, you'd say 61% or more, because the function is greater than that, greater than or equal to, of U.S. households have internet in 2007. That's how we started, okay? Or you could say at least 61% of U.S. households have internet. There's different ways to phrase that, greater than or equal to, okay? So that is what you're doing for number 8. And then I want you to turn to number 9. Now this time gives you a function, h of x, and here's the function. And it wants you to find the value of x for which h of x equals -7. So it doesn't give me x. It doesn't give me something inside the parentheses that what I'm replacing x with. It gives me h of x equals this. So that means in this equation where I have h of x, I'm substituting in a -7. So I put -7 then equals 2/3 x minus 5. And then I'm solving a two-step equation. I'm going to add 5 to both sides, and I get -2 equals 2/3 x. And I need to get x by itself, so I'm going to multiply by the reciprocal of this. So I'm going to multiply this by 3/2, which means I multiply this by 3/2. These 2's cancel to 1. Those 3's cancel to 1. 1 times x is just x. This side, I get a 3 times a -2, would be -6. divide by 2 would be negative 3. So there is when, if I said h of negative 3, and I plugged all that in my calculator, I would get negative 7. Okay, and then you're going to do number 10.